things and the opportunity to network with experts and seek their help. The main purpose of our webinars is to help developers learn new frameworks and tools that make them productive at work. We bring great speakers from the tech world to talk about new tools, languages, and frameworks. For today's webinar, we have a great speaker, Karl-Heinz Modbase. Karl joins us from Germany. Karl is the chairman of the Apache Maven Project. So no better person to talk about what's happening in the world of Maven than Karl. Karl works as a freelance consultant on projects involving Java, Apache Maven, JUnit, Jupyter, Spring Boot, Jenkins, Gitya, GitHub, Nexus, Docker, and several other tools and frameworks. He has worked with several clients in critical engagements in a career that spans several years. So just to move on to the topic for the day, as programmers, most of us know that in a world of CI/CD, good build management is critical, and Apache Maven is popular with developers because it is powerful and easy to use. And in most instances, if you're working on a Java Spring Boot project, Maven is sort of the first line choice for build management. So no brainer, right? So everybody picks Maven. This talk, therefore, is sort of intended to give you the most recent information on what is currently being developed in the Apache Maven project, and we will show several features. For example, the build versus consumer form XML, which are already implemented, and certain features and improvements that have been rolled out recently. The presentation will also talk about some extensions that could possibly break backward compatibility, and therefore it is critical for you to keep those things in mind. So as is typical with our webinars, the session will take about 50 minutes, and we will have an additional 10 minutes set aside, 5 to 10 minutes set aside at the end for Q&A. And yeah, if we don't have time, we could always reach out to Karl at the end of the session. So Karl, it's a pleasure to have you on the webinar. Thanks for taking the time out. Over to you. We can begin.
Okay, thank you, Shashi, for introducing myself. I will change and share my screen here for you. So I hope everybody will see my screen now, hopefully that works. So if someone has a problem, please speak up, that would be helpful. So you should see some lectures here on some slides here.
Yes, we could.
So what I would like, okay, good. That's first, very good. So the most important thing I would like to talk about is what the state of the current development in Apache Maven as it is at the moment, because we are working towards Apache Maven 4. Maybe many of you have already used Apache Maven 3 point whatever, but we are talking about the future here, and we would like to go into the future because we need to do some special things to change things and maybe break, as already introduced me. And there are a lot of things which are going on at the moment, and big issues maybe, and big improvements, maybe changes and things like that. And that what I would like to give you a more detailed overview of what is happening and what we are planning to do. So let us start with a very simple thing here. I have some slides here for that, and I will show you most important things. The first thing, just a few other words about me. I'm committer for the Apache Maven project since 2013, started as a PMC member in 2014, and so on. And since that April this year, I had been becoming the chairman of the Apache Maven project, and I have elected for that. That's a very good thing. And I have to do some other things here. So what I would like to give you an overview about the Maven ecosystem, some more details about the architecture of the different Maven versions over the time and which has been changed. In particular, as you already mentioned, the built-in consumer POM, which is very important to do some future stuff, because that's the most important thing we need to do. Maybe some information about the current roadmap, and in the end, hopefully some time with some questions, for example. So let us start with some very important things. Of course, I'm saying several things, but don't get by that for 100% sure, because the community or the other developers can vote different and make a different decision, because I have a particular view on things which are done in the Maven project. Most of the time they are match, but there are sometimes differences. So don't get that too serious. Most of the things are more or less clear, but there are some things which are not clear at the moment because we are discussing a lot of them. So let us start with some overview about the Maven ecosystem. We have in the Apache Software Foundation a large number of components, plugins, and the Maven core. On the upper left side, you see the so-called Maven core. Developers call that Maven core. That is the one which you usually download from Apache Maven. And that's the one which you usually start from the command line or via MVN or something like that. So that's the most important thing here. That is the so-called Maven core. We have a lot of supplemental things. There are some other things like the Maven plugins. A lot of them you are already using them. For example, the clean plugin, the compiler plugin, the resources, install, deploy, jar, and so on, so on. These plugins are developed in the Apache Software Foundation and under the hood of the umbrella of the Apache Software Foundation. Also, another lot of tools or things which we are maintaining here are the so-called Maven Parents, which are used by the Apache Software Foundation in the project, which are using Maven, and to help them to maintain the correct versions and things like that. We do that for our plugins and the shared components, which we are developing as well. We do that the same way here. Another part here are the so-called shared components, which are code which we have extracted from all the plugins, which are needed to be done in always the same way. For example, Maven Archiver is intended for creating archives like jar files, zip files, target set archives, or something like that. And that's most important here, that we have these different things here. So we do that with different components and have extracted that. The next thing we have here are the so-called doxia, which is responsible for generating site content. If you do an MVN site or something like that, and generate from different formats into HTML, which you can distribute and publish onto on a site or something like that. For example, the whole Maven Apache org is done by that. It's distributed and published by Maven itself. So the whole pages are done by Maven itself. So we have so-called skins, which is a kind of a theme for the different looking and things like that. We have also the archetypes is a kind of a template to generate new projects and things like that. And also we have a so-called artifact resolver that has been integrated to the Apache Software Foundation at 2016 because it has been developed in earlier days in Eclipse under the Eclipse hood in the Eclipse Foundation, which produces some problems because based on the maintenance, because there are not enough developers at that site. So we have to decide to integrate that during a time of about a year to integrate that into the Apache Software Foundation, that we have it easier to maintain that code. And it's now since 2016, we are releasing that as part of the Apache Software Foundation as well. That was really necessary to get more development speed in there. What we also have is another part which is outside the Apache Software Foundation. These are the so-called codehouse plugins and components. If you see the name, maybe you have already seen that sometimes, the Plexus class words, for example. If you take a look into your Maven installation, you can look at the directories and see there's something like Plexus class words. That is one of the parts which is responsible for the bootstrap of Maven itself here. We have Plexus Modeller, which is responsible to read or generate the code for reading the POM file, which is done by that. The interpolation, for example, is responsible to interpolate values, for example, $project.version or something like that, or other properties inside your POM. And the archiver utils IO and have different things in common. At the moment, we are just trying to get out Plexus utils and Plexus archiver because we have already, as you've seen before, a Maven archiver, and there have many code parts in common or duplicated. And so we are trying to figure out and get rid of Plexus archiver over the time. It takes some time here. Then furthermore, we have so-called Mojo House, which contains a lot of other plugins like the versions Maven plugin, the Flatten plugin, exec plugin, RPM. And I would say the version plugin is used a lot of times, or the Flatten plugin is used a lot of times, or exec plugin. Maybe the others are not that known for that, but I think there are I make more or less a bet that you already used those plugins, or at least one of them. As you can see, here is an overview of the architecture of Maven at 2005 of Maven 2. So you see a very, very interesting thing here on the left side. There is a complete reporting API included into the Maven core itself that has. At that time, if you downloaded Maven, you already have some reporting part. That means generating site and things like that. So it was very difficult to change something into the reporting area because it's really coupled to the Maven core. So that was a decision later made to extract this reporting API and the implementation out there to make that available as a plugin, which has been done in Maven 3 and has been completely extracted and removed from the Maven core. Plus, there had been some enhancement on that. In particular, you see on the downside here, Plexus being juice patches on the downside, so-called Zizu. That was a compatibility layer for running Maven 2 plugins in Maven 3 at that time. So there had been other things, report extracted and things like that. And also you see the ether part here on the left side down here, the SPI implementation and so on. That was this Eclipse ether that was responsible for the transportation of the things here. And that has been changed over the time a bit to get more clean architecture and not breaking things and make implementation easier and things like that. We started with that to Maven 3.5 in 2017. As you've seen, the migration had been done in 2016, and then we changed that and introduced that in Maven 3.5 and changed all these implementation. And down in the left corner downside, you see now the name Resolver, which is exactly that we replaced that. You see also some logging APIs, logging SLF4j, for example, on the left upper side. And on the left side, you see some yellow boxes here with JANSI, for example. And that was the time we introduced the colors on the console. But also a very important thing was to change the injection framework. Because we used at the beginning of Maven, Plexus was used. This was a dependency injection framework. At that time, there doesn't exist really something. And so it has been implemented on different sides. In the meantime, we have replaced that with one layer of Plexus, and then you see down on the last line on the slide, very down there, the juice. And that means starting from 3.5, you can use the default JavaX inject, at named inject, at inject, and things like that, these annotations. But also it continued to work in plugins to use the usual Plexus annotations. So at that time, you can already migrate that. And that was a very important thing to change that. And in the meantime, you can completely use JavaX inject instead of some kind of Plexus. Hopefully, we can completely get rid of that with Maven 4, for example. On the other side, class words and so these things, as I already mentioned, was outside the Apache Maven Software Foundation here, the Plexus part. And then we are coming to Maven 4, and that's the current view we have at the moment here with the architecture. The most important things here are toolchain has been changed a bit. We have some builder support in the middle here and model transformation. And the model transformation here is a very important thing that we can do and change a lot of things, which I will come later to why we are talking about the so-called consumer and build POM here. On the left downside here, you see the resolver part, which is there. We have at the moment one drawback at the moment. This is called the compat. That is a module which is compatibility layer, which is used from Maven 2.3 at the beginning. And we want to try get rid of that because it's a bit nasty to maintain and things like that. So what we have here now is to change the architecture a lot. But this was necessary to get some advantages of that, because in particular, the model transformation was very important. So one thing, if we are talking about the POMs here, you can see that the point is that we are using the POM, which at the moment has been started with Maven 1, There was some model version 3, and today we have some model version 4 at the moment. So you see some contradiction between the Maven versions and the model versions, and we will hopefully change that for the next step here. But in the end, if you take a deeper look on the POM, I will later come back to the answer, the question of the JDK, which is asked on the chat here. At the moment, we are doing several things in the POM file at the moment. We are declaring dependencies, we are declaring plugins, profiles, builds, reporting, distribution management. If you take a deeper look on that and trying to understand, we have at the moment 2 responsibilities in a single POM file. That means we are declaring one side is the description of the build process itself, how to build things, for example, executing some plugins, executing some source code generation or whatever, executing the compiler plugin, the tests or something like that. And the second part is just the description of the dependency graph. That means we have defining dependencies which you are consuming on the other side. If you're distributing something like that, is something like that which you can consume. But if you take a look on the other side of the user and say, okay, I would like to consume this library or this tool, whatever, you are not interested into the information of how that it's being built. For example, if you executed a source generation tool, or if you execute the whatever compiler plugin or Surefire, or whatever you do, that is not interesting for the consumer part. So we are tending to make a difference between a so-called consumer POM, which contains only the dependencies which are needed, maybe some kind of dependency management, that might be a part of discussion, and also the information of the build POM here on the other hand. So we have something, it is called a build POM, which contains only the information which is needed to have the build information, how to build that, contains also the dependencies, and there need to be a step in between to make a clear separation. The problem is we have several parts in the POM which are not used anymore or not a good idea to use that. For example, the information, for example, if you put some repositories into a POM file here, that's a bad idea in general. Maven Central, for example, prohibits that using a POM which contains references to different repositories. That is a kind of a way to make a denial of service attack or something like that, and changing that, and because repositories changing over the time, and many other aspects of that as well. So, and the other way here is to think about who's using that format. We have a lot of tools, different build tools, for example, Apache, Gradle, Ivy, SVT, and many IDEs, for example, IntelliJ, Eclipse, NetBeans, and all the IDEs of today are using these different information in the POM file. And the point is, why do they using that? Because they can read that. It is very easy. It's technically easy to read that. But there is a difference here, and that's the big problem here on the other hand, because it's consumed by many, many, many tools. So the problem is to get a separation here between these different targets, for example, saying one is the consumer POM and one is the build POM, that must be separated somewhere. So how can we change that? So we can do that and think about we need to change something like that. If you change just simply the POM format, for example, add some tags or remove tags or whatever, that would mean that we have a different POM format, which is not consumable by any other tool in the future. And that means we are breaking things, or breaking a lot of things, to be honest. I would say breaking the world, because we have so many consumers in the end, and that would result in a bad take here. And most important is, if you think about a change in the POM file, take a look into Maven Central, there are 500,000 of different artifacts in there with only group ID, artifact ID, not to count the number of versions. There are 20 million or something like that. That would mean you have to change Maven Central for that. So anyone has to change and do the work for that. And that would be a bad idea. In the end, it would break anything and would never be accepted, nor it is a good idea, because this kind of stuff we already did in a long time ago. And that was at the time from Maven 1 to Maven 2. And the repository format already had changed and migrated there. And the experience was simply bad, to be honest. And that's the reason why we shouldn't do and will never do that. So we make a separation on that kind, as Gradle did already. It's sometimes the same thing, and other tools are doing that same thing. They are just simply generating a so-called consumer POM, which contains only the relevant information to consume a library or a tool, which contains dependencies, dependency management, and things like that. That is the way to go here. We have thought about different things like that. We would like to create a so-called build POM here. We have a so-called build POM on the left side, upper left side, down there, the POM version 5, which is consumed by future Maven versions, maybe not Maven 4. Parts of that is already changed. And then we generate from this by distributing to a repository the default way and a POM version 4 without any change. So we can make that easy for using and consuming that. So that gives us the opportunity, if we have changed that and separated that we can evolve Maven here and removing things like that or enhancing that using different kind of formats, maybe using attributes in Maven POM for group ID, artifact ID version instead of full text or something like that, or completely changing the format in the future, as long as we do and produce a consumable format which is deployed to some repositories, for example, central repository. What we also thought about is to create different information or supplemental information which has been deployed to the central repository as well. We call it at the moment a so-called project dependency tree, which is a pre-resolved tree of all the dependencies, including the transitive dependencies, which on the other hand can be used to consume that and make bulk downloads from a repository manager and make that much more faster. There are a lot of things which are building up. The basic thing here is to make that separation here. And that's the most important thing we need to do. So we have decided at the moment, and so far we're at that point, we have a so-called Maven consumer POM, which is a POM version 4, which you already know, and without some supplemental in things like the properties will be removed, the build part will be removed, the modules as well as the parents. You can do that already in several ways to do by using the so-called flattened Maven plugin. And there is downstairs a link into our wiki, which shows some much more detailed information about that. And what we have to do is, or in which way we have to go is, we have to be able to read the POM version 4 as well as version 5, whatever we do that. At the moment, we are not at that point exactly. We have some issues with that. But in the end, Maven Core, what you're calling on MVN on the command line, must be able to produce a version 4 POM. That only means that in the future, if you would like to read that build POM, which is usually checked in with your source code as well as the source code itself, must be able to read that. Then that means you have to use at least, for example, Maven 4 or Maven 5, whatever version we are talking about in the future, to build your project. Not on the other side, where you use the consumer POM, which is containing only a version 4, which means you can consume that. So let us take a look and take a look how that really looks. And give you some example here. I hope you can see my IDE here at the moment. Does it work? Can someone give me a feedback here?
Yes, can.
Okay. So I have here just a simple Maven project, which contains of a parent here, which has some supplemental modules here. And as you see here, the usual way here is we define a version, which is fine. And if you take a look in those submodules, for example, I have here defined some modules here, so-called multi-module build here, several modules. Each module, if you take a look into each module, you have to define the version here in the parent. That's the way it is at the moment. So you also define a project version to reference another module within that build. And you can build that without any problems. Today with Maven 3, that works out of the box, no problem at all. But if you really think about these steps here, there are some steps which might be improved, and which is a good thing because that can be improved in several ways. Let me go to the console here. So if I just take a look which version I am using at the moment, I'm using here Maven 4 already. It's a current build from Maven Master at the moment, built yesterday. So I can do that as well with the Maven 3.8.4. There's no difference here. I can just simply compile that, verify, just simply build that. That's nothing fancy here. That's the usual way. That works with all the Maven versions. But now the interesting part comes, how can we make the separation with Maven 4? So the first thing you see, a usual Maven project works. There you see already some warnings here, and that's one of the things which might break some things in the future where we have some changes in particular plugins here. But we are working on that to get that better and get the warnings away here. And you see here some other problems. That's a very old plugin, which is not upgraded to most recent dependencies and things like that. That is the work we need to do in the future here. So let us take a look and do some changes. Step 2. So now let us take a look how we can change that. The first thing is we can use a property for defining the version. Let us take a look here. You see that I now have a property which can be defined here. Revision, I call that. And if you take a look into the component here, you see that the parent also using this revision property. This is one of the things which is already today possible, which can be used, and it's called the so-called CI friendly. But it is needed to set up the Maven Flatten plugin for that. So that means you have to make a supplemental setup and things like that. That's a bit cumbersome and maybe error prone and not that flexible and things like that, maybe supplemental configuration. And also, it also requires a particular Maven version, which is very good, but you have to do that. So I have changed that, and in all the parents, I have just replaced this with the version here with these properties. So now I can compile that as well. So the big difference here is that I can use that is one thing I'm using a configuration file, which is called mvn maven config, which contains simply a dash revision 2.00 snapshot. That means this is picked up by the command line, and you can change that version. I can change that in the file, but I can also change that by just using the revision here, 1.3.4, whatever, without any big problems here. So what you can see is that in the meantime, the core here already uses that correct version without any changes. I don't use the Flatten plugin here anyway. So if I do that and just do an install, or as a preparation step to make a deployment later on to a repository manager, for example, I can do that and install that just to see what's happening. Of course, it will install the artifacts here. So I have to use and take a look into my own local cache here. Take a look here. We have now the versions here. And let us take a look what happens here in the different directory. And now the interesting thing here is the POM file, which has been written. What you can see here is that the install plugin does not contain anymore this property here, that it has been replaced. This is more or less the same thing here as you can do with the Flatten plugin, but this is at the moment implemented in the core. That there is no need for supplemental configuration or plugins here. And that is most important. So we have already a transformation into Maven Core already. So that is only the first step to do that. What we have here is things like this here. There is a property used to reference to the different project, which is a bit supplemental work or even some not so good work. So let us go back and see a different aspect here of the project here. So git check out. So let us take a look. I now using a different thing, so which is much more important. I have changed this, and what you can see is I have defined the property in the root project here, in the root of my multi-module build. But if you think a little bit later or more in detail how the relationship between the different modules is, the usual way is that one subcomponent or child is by definition finding its parent in one level higher in the directory hierarchy. So that's the usual assumption here. That's the convention over configuration. You can change that. For example, if I'm going to the web GUI as a component as well, what you can do is, of course, there is something like a relative path. If you need, you can do that, something like that. That is possible. What not the best thing, because the structure should represent what you're really doing there. You can technically change that, but the most important, follow with the conventions. If it's just a child, just make a child there. If you need to have a relative path, something like that, usually that's not a good idea. That works, of course, there's no problem, but the other way around, it makes it easier. If you think about that convention here and defaults, then you can say this parent here is by definition one level higher. So you don't even need to mention the version here, because you can automatically conclude that the parent is automatically one level higher, which is, in other words, the parent which I used here. So I can completely omit the version in all the parent definitions. One thing what you're seeing here is that my IDE is already complaining about that, because the child tag should be defined here, the version tag should be defined. And that's exactly one of the points where we need to change the POM version here, or the model version more precisely. At the moment, we don't do that because that doesn't work at the moment, and none of the tools actually are doing that work, because we have not even released an alpha release or something like that. So the tool producers can't even follow at the moment. That's one of the reasons we need to change, which makes sense. So if you take a look on the difference here, I have changed that for all the parents, so I don't need to give a supplemental POM version here. What is the advantage of doing that? The advantage is simply, if you think about on larger setups or larger multi-module builds, in particular, if you make branches and want to merge later, there is always the option here or opportunity that if you merge different branches together, then you get conflicts, in particular into the revision number of the parents or something like that. That makes it easier here. That is already possible by using the property, but then here you can completely omit that, and that makes it easier. So let us take a look how a build of that looks like on the command line. So I can do the same thing here, do a clean install, just wait to remove that, make it sure it doesn't make something wrong here. I can change the version number 5.6.7 or something like that to be absolutely sure. So we have a difference here. So what you see is the different versions have been generated. And also, if I go to my local cache here, I'm using the same way here. What you can see now is that I'm using the POM here. And what is important to see that the missing version tag has been automatically re-added here to make it really a valid Maven version model version 4.0.0 POM file. And that's very important that exactly this kind of transformation is possible. That's only the small steps we are doing at the moment to be sure that that is working, because later we need to do more things, but that's the first step. We can do that. And all of these modules have now the correct version. We can just check here the different parts here. For example, I don't know, service client or something like that. We can take a look here into the POM files. So you see the version has been replaced here. So this is one of the things which can be done. And later we need to think and reconsider, maybe we will remove supplemental things like the parent at all. The parent is not needed if you only have dependencies. Then you don't need the parent. The parent is only used during the build time and maybe some default. And usually that is dependency management, or if you need some build information. But if you just looking from the perspective of the user, you don't even need it. So let us take a look and reconsider that thing here. Most of the time, people are using two options of making things clear into a larger build. If you would like to define some dependencies between the modules, for example, I have a service here, and I would like to have a dependency on the service client, which is the other module here. The usual way to do that is to define a dependency between these modules, which is the only way to have that, because you need that on the class path to compile that. In consequence, that means also defines the order in which the modules are being built. If I have a dependency here, that means I have to be sure that the service client must be compiled before the service, because it's using that, so it must be compiled before. That's it, automatically the definition in which order the Maven modules will be built automatically by Maven itself. So the question is here, on the other hand, do we really need to make this version here written down here? In the end, if you really reconsider that and very deep thinking about that, you will come to the result that it's not necessary. The only thing you need to find out if this group ID artifact, the ID, is contained in your so-called reactor. If you're running the build, you have a limited number of modules or components or artifacts which are being built during your multi-module build. And that means you can automatically identify if some of the artifacts, for example, this one, is part of your multi-module build. If that's the case, you don't even need to define this version. You can simply omit that as well. And that exactly is the next step we are doing. So we are doing that the same way here. And now we are changing that and removing that also. So you can see that in every module I mentioned here are that it is automatically identified by the group ID, artifact ID, that it is automatically part of my multi-module build reactor. And so I don't even need a particular version or define it via a property. That's sometimes a bit unclear, because based on that usual $curly project version, it's most of the time automatically can be read and identify that this is automatically part of your reactor. That might get a bit problematic because you don't see it directly. If you have a very large build, maybe hundreds, 300, 500, 1,000 modules or something like that, you don't know exactly all the group IDs, artifact IDs or something like that. That might be an option, but in the consequence, if you think about that, that it's possible too. That's one of the things. And now we can build that project as well. For example, I can just simply just install that. I will remove that first to make sure. So I will use a different version here. Make a complete different version here now, just with 2 digits here. So you see this compiled without any issue, of course, hopefully. Otherwise, I would have found a bug here, which is not unlikely, but that could happen. So we take another look into that POM file here. And now we see that things happened here. As before, the version has been added automatically as a supplemental information to make a valid Model 4 version POM file of that. And also it is automatically added that the version has been added to the parts where we have defined dependencies within the multi-module build here. That is automatically replaced and automatically inserted here. What you can see here is one very big step, that we can generate parts of the resulting POM file in the end, which hasn't been there. So we can generate at the end an automatically valid Maven 3 POM version 4, model version 4, more accurate here. And this separation here is the most important part we are doing at the moment in Maven 4. Apart from that, we are doing a lot of other internal stuff. We are cleaning up the code. We are removing things like compatibility with Maven 2, Maven 3 sometimes, Maven's particular issues here. We are changing some of the plugin APIs, make them more immutable than mutable as before, and things like that. That is a very important thing here to have that working. There are also a lot of improvements about handling the reactor and things like that. That is very important to make a resetup of a failed build and a multi-module build. There is a complete video, different videos about that, telling you more of the details here. So that is the most important thing here. So now let us come to a more general view. There had been some question about the minimum required JDK. I will come to that point directly here. So let us first think on which kind of roadmap we are at the moment here. At the moment, we have Apache Maven 3.8.6, the current release. The minimum required running version of the JDK, which is needed to run Maven 3.8, is JDK 7. That is the absolute minimum. It works, of course, in JDK with JDK 8, 11, 17, 18, or even 19. That's no problem. The point here is the minimum required version for running your build. Then we have decided for a few weeks ago then that we want to make a Maven 3.9 release. There are different reasons for that. The first one, we want to lift up the minimum JDK requirement to JDK 8. The most important things while we are doing that is a preparation for Maven 4. We are doing some changes in the APIs for the different plugins, the plugin handling, some executions, internally stuff, cleaning up things like that. That is very important to do that, to have a more smoother path to Maven 4. And after that, we already announced, maybe some people have already read that, I have asked the question for the community, which JDK version should be Maven 4. And there is a different or very interesting results, maybe some misknowledge or unknown things. We are trying to do a first alpha release this year. I don't know when exactly, but we are trying to do that. If it's not coming, okay, then it will not come. So the question here is, in the end, should at least required JDK 11 or JDK 7? So there was a big discussion on different channels here. We have some opportunities to handle that. The idea here is to use, or from my perspective, JDK 17 should be done for that, because this year we have already JDK 17. Next year we have JDK 21 is in September, the next LTS release. So we are on the next step already. And I'm not sure when the final general availability version of Maven 4 will be gone out. That will take some time. The acceptance rate is something different here. And on the other hand, if we do that, we would like to take the advantages from some particular JDK features, for example, seal classes, things like that is a very important thing to close internal stuff, really make them closed up. So that is one of the reasons to use JDK 17. Also, some other big frameworks like Spring have announced that with their next major version, they will require definitely JDK 7, for example, 17, sorry. And always the same discussion coming up. We need to keep JDK 8 or even 7 or even lower. That's a problem, yes, sometimes. There are some things to say about that. If you're using JDK 7 or in general JDK 9+, you can use the release option to generate code for different target versions. That's possible. If you have really challenging things like you have to use a particular JDK, I don't know, maybe an IBM J9 or something like that, or whatever we are talking about, you can do that and use the so-called tool chains. That is also already possible for about 10 years or plus, since Maven 209, as far as I correctly remember. I've made a YouTube video about using tool chains today, and that's very easy in the end. So if you have really the problem, you can't use JDK 7 to build your application, for example, JDK 7, and make the target maybe Java 8, for example, and that doesn't work for whatever reason, you can really use tool chains to do that. Most of the time, I think it's not necessary, but there are some edge cases, of course. Yeah, that's true. And on the other hand, if you can't accept that or can't update for whatever reason, there are a lot of things like to talk about that. You might use an older version of Maven 3, for example, Maven 3.9 in the future, if Maven 4 will be finally released, the first version. That is one of the most important things we are doing at the moment. That is based on the Maven core here. So we are going forward. We need to go forward for different things. Most important, make the difference here. That is very important. What we are also doing a lot is in background is a lot of things are upgrading the plugins at the moment. There are existing at the moment plugins which are compatible with Maven 3.0, which is extremely old and produces some problems between the compatibility and the maintaining of the code. And we are cleaning up a lot of plugins to require at least Maven 3.2.5. That is really necessary to get rid of some supplemental compatibility layers, implementation, and things like that. Most of the plugins are in the meantime updated to JDK 8 minimum. And to be honest, no one has ever claimed about or written an issue about that you can't use at least Java 8 for that. So it's a very important thing to do that and cleaning up and get more maintainable code here. There are a lot of things cleaning up. For example, in SCM area, we have removed a lot of old version control systems we have no access to, and we are cleaning up that API as well and doing a lot of stuff in that way. The Maven core itself, we are cleaning up a lot of code, removing things, migrating to JDK 8, at least using Stream API and things like that, or functional setups and things like that to make it easier, and in particular to make it easier to handle, because cleaning up the code, removing old stuff and things like that. The complete API is changing at the moment, in particular in relationship to the Maven plugins. We have some branches for all the plugins for Maven 4 and seeing where are the differences. And at the moment, it looks like we can handle that with an update with Maven 3.9 as a preparation step to look up into the direction of Maven 4 and not to break too much things. We hope we will get that. The problem is that many plugin authors in the wild out there are using very old dependencies of the Maven and not updating them. And I think there are a lot of plugins which might work in Maven 3.9, but I think there will be some breakages there, at least in Maven 4. But I think that takes a lot of time, of course. And at least if someone is updating, you will find some problems, and then you can file in an issue at the author of a Maven plugin or something like that, and say, here, that doesn't work. Can you please update that? And most of the authors have no problem to do that. But most of the time, they are not even aware of that. So it's most important to report things and issues on the appropriate plugins and the authors of the plugins and so on, to make them aware they have a problem here. A few days ago, I had some problems with the JDK 17 problem, which produces some wrong error messages. And I have made that or filed in an issue to the author of the library, and it took less than 2 weeks to get a new version, which works now perfectly. So it's most important to report things like that. It is also very important to do that in the Maven Apache Maven project. If you find some problems, please file in an issue. Please get the information to the Apache Maven team. That's very important. And also, please, the first step, always use the most recent versions of plugins. The plugin updates you can find in Maven Plug-Ins here. That's the most important page you need to visit from time to time, or use update tools like versions update and show dependency updates or plugin updates, or use Renovate or Dependabot on GitHub or something like that to get this information that something new has released. That is very important. And then step by step, get the updates in your build. The build needs to be maintained like your code does. There is no difference. The build must be maintained as your code. You have to refactor them, improve that using different frameworks, updating the dependencies and things like that. That is also necessary for the complete build as well. So not keeping your build for 10 years unchanged and then blaming some people on Stack Overflow, let's read that, using 15-year-old plugins which do not work with JDK 16 or something. I'm really not astonished in such cases. So use the most recent, they are working. So I think based on the time I see, we have about 10 minutes or a little bit less. So we can open up some questions here, I would say.
Okay, great. So this one question, I think, from Divyansh Bharadwaj, do you want to like take a stab at that first?
Yeah, that was the question about the minimum JDK. I also given some more details, why and when, and Maven 3.9, things like that.
Right.
Or I already given the information.
Right,
Or
that's correct. Yeah, yeah. So and then
okay.
I have some questions that got forwarded to me. One question is about Maven being a little slow. Do these upgrades tackle that aspect as well?
Yeah, the question is what you mean by Maven is slow. The most important thing here is to use the most recent versions of Maven. There have been several improvements about performance done over the last 2 years. If you are using Maven 3.6, for example, upgrade to the most recent one, because there had been a lot of improvements there. And also use the most recent version of the plugins. Please, that's really important, because there had been improvements a lot. For example, jar plugin, assembly plugin, compiler plugin, and several other things had been improved. If that is that not enough, you can use the -T option to build in parallel, your modules in parallel if you have a multi-module build. That improves a lot. For example, running with 3 or 5 cores or something like that. I can show you that here very. Let me take a look. Clean verify -5 or something like that. You can do that, and it will run automatically in parallel. And then you see there is a problem here. Yeah, just give me a second. I will change to the most recent version here. Just a second. Sorry. Yeah, that was mine. You can do something like that. If it works, yeah, sorry. Git check out step 1. So you can use the -T option, which improves a lot here. Oh yeah, there is sorry. Just give you a difference here. Core Maven. Git switch master. So let me take a look, and you can do that and build the whole multi-module build in parallel, and that reduces the overall build time a lot here. You can use -5. There are some plugins which are producing such warnings. Then you should get in contact with the authors of the plugins to improve that, because there is only a configuration in the pumps in the plugins itself. That should be used if you have a large build that can improve the build times up to 20, 30, 50%. So if I use only a single thread, you have seen 28 seconds or something like that. And if I use just a single thread build here, it takes a lot longer, of course. I have to say that it's a very fast machine, which I'm having here. There is a big difference here. And the larger the build or the more modules you have, the more you get out of that and more improvements you get. There's also existing a so-called Maven Daemon, which you can use that, which internally does more or less the same here with some supplemental informations or supplemental configurations, which make it a little bit faster than that. You need to test that, and you can take a look at that. And yes, there you see here, there's an 8 or 10 seconds difference here. That's a very small build here. We have only 20 modules or something like that. If you have module hundreds or 200 or 500 modules, it improves a lot, much more.
Right.
And also using most recent JDK version, which improves the speed as well.
Got it. Yeah. That's good. So, and then the other question that I have is with respect to the IDEs, the older versions of Maven obviously had some issues with, the plugins, not Maven itself, but VS Code, that's something that a lot of developers use these days. So, as far as you are aware, how does VS Code work with the plugin for Maven work with the latest version?
Yeah, you should work with the latest version of your IDE. Mm-hmm. I'm using IntelliJ only and Eclipse as well. So you can do that and use also the most recent version of Maven also, because some of the IDEs, for example, IntelliJ as well as Eclipse, are coming with an embedded version of Maven sometimes. If it is more or less the same, then it's usually not a problem. But if you have a difference because you're using an older version of your IDE, which is usually not a good idea, use the most recent one. They have improved a lot the support over the time, in particular for Eclipse as well as in IntelliJ. I know that over the last 2 years in IntelliJ, the improvement has been a large step forward here, much more better control, better support, better error finding, and also keep the plugins up to date. That is very important here. That's exactly the same thing here. If you have a build, for example, where you're using an Eclipse, I had some weeks ago and asked a question on Stack Overflow, whereas someone is using an Eclipse about 5 years ago and had some problems. Okay, you can do that, but I don't recommend that. Yes, you can do that. You have to update your tools. That's really necessary in the meantime. In relationship to the Java release canons, which have been changed over the time. And that's becoming more and more important, that you really keep up to date your tools. That means your IDE, your Git, for example, your Java version, as well as Maven itself, for example.
Right. Yeah. That's great. Yeah. And this is a question that we get asked quite a bit, Carl, and this is about, I know, the Apache Maven site has excellent documentation. But apart from that, do you have any learning resources to point to on the internet for somebody who's just starting?
I think, yeah, the problem is, in general, it is okay, to be honest. Yes, it is not perfect and can be improved. I can always recommend, if you don't find things on the Maven site itself, then please open up an issue for that and describe your problems. Maybe either you get already a reply on the issue, or just subscribe to the users mailing list or on Stack Overflow. You will get answers for that. Because the problem is, of course, some developers don't like to write documentation. To be honest, me included. Right. I'm not exception in that, and all other developers as well. But if you like to improve that, please, that's also a good way to contribute to the project. That's not only code. Documentation is very important. That's also a very good way to contribute to an open source project. Yes, if it's not perfect, or just either use on the user mailing list, on Stack Overflow, or maybe just call me directly via email or via Twitter or something like that, if you like.
Right. So that's great. And Carl, thanks for a really wonderful session. So it's great to see a survey of the Maven landscape, and then to get a sense of what's coming and stuff like that. And I think one of the most important takeaways is that we have to maintain, like you rightly said, we have to maintain the build like we maintain the code, because most programmers do the build just once and then just try and run it. So yeah, I think that's the most important part. Agreed. So thanks for a very insightful session. For people who have joined us, want to quickly tell them to follow Carl at KH Marbais, MARBAISE on Twitter. Always interesting posts and tweets and stuff like that, not just tech related, but yeah, you could go check his profile to see interesting stuff there. Thanks a lot, Carl. Really enjoyed having you here. We'll try and get you back for another session soon.
Okay, that would be great. Yeah, thank you very well for your time, and hopefully you learned a bit and I can get some information on there. Thanks very much for showing me. Thanks a lot. Yeah.
Yeah, thank you. Bye-bye.